Welcome you all. Today I am going to explain about electrochemical theory of corrosion. In the previous video we discussed about what is corrosion, how corrosion takes place, and also we discussed about the different types of corrosion. So how this corrosion happens on the surface of metal, so that can be explained by electrochemical theory of corrosion. So now we have to take iron as first example. So first we have to take the surface of iron and which is exposed to the surrounding environment. Whenever it is exposed to the surrounding environment, immediately these reactions are not takes place on the surface of metal. It requires some periods of time. After knowing the types of corrosion, we come to know what is the time duration, minimum or maximum required for the corrosion happens on the surface of metal. So for example, if you take the iron surface and that iron surface is coated by a paint. After some periods of time, a small peel of paint layer is removed from the surface of metal. So by the time the direct surface as well as the coated surface is present, then it causes two regions on the surface of metal that we call it as a formation of minute galvanic cell. The direct surface of the metal is considered as anode and the coated surface of metal is considered as cathode. So hence the formation of minute galvanic cells are happening. So second one is anodic reaction is observed. So anodic reaction is nothing but the oxidation reaction. The metal undergo oxidation gives to the metal ion and electron. Example here we took it as iron. So iron undergo oxidation into Fe plus and 2 iron. So the corrosion starts on the surface of metal due to the oxidation reaction. Then afterwards the next step is cathodic reaction or reduction reaction. So this is based on the surrounding environment. So based on the surrounding environment, what are the possibilities of the conditions are present? So due to that nature, the reduction processes takes place. So here I explained two types of possible cathodic reaction. One is the oxygen absorption type, another one is hydrogen revolution type. So see, the first condition is if a solution is aerated and almost neutral, nothing but the way the metal is present, the surrounding environment is having aerated condition, nothing but presence of oxygen. So in your equation also, you are using oxygen because the condition is aerated. So oxygen and moisture content is present, the electrons are liberated at the anode is used for the reduction reaction. Due to this reaction, you will get the hydroxyl ions. So hydroxyl ions are present on the cathode surface of the metal. This is called as oxygen absorption type of cathodic reaction. Second one is the condition is de-aerated and almost neutral condition. Nothing but the surrounding environment not having much amount of oxygen. So that is called as absence of oxygen. So by the time you are not supposed to use the oxygen molecule for writing the chemical reaction. So you have to take only the moisture content and electrons which are liberated from the anode is used for reduction. So you will get the products as hydroxyl ions and hydrogen. So again one more possible condition is de-aerated condition and acidic in nature. Again you are not using the oxygen but the surrounding environment is acidic environment. So by that time you have to use the H+ ions and again you are using the electrons which come from the anodic reaction and you will get the hydrogen gas. So these two types of cathodic reactions are examples of hydrogen revolution type and this is called oxygen absorption type. These are the possible cathodic reactions observed on the surface of metal. So not all the equations take place at a time on the surface of metal. So based on the surrounding environment, any one cathodic reaction is observed on the metal surface. So the oxidation reaction takes place and reduction reactions also takes place on the metal. Now further chemical reactions are takes place. So whatever the cation which are releases during oxidation, whatever the anion which are releases during the reduction reaction, they are diffuses towards each other. It undergo a chemical reaction. It produces the metal hydroxide. So this metal hydroxide is highly unstable. Immediately it undergoes oxidation in the surrounding environment and produces the iron oxide. So hydrated iron oxide Fe2O3 NH2. So this is called as the reaction takes place at the surface of metal is equal and opposite to the rate of reactions at the cathode. Because anode undergo oxidation with loss of electron, cathode undergo reduction with the gain of electron. So this is symbolically we represent the cathodic reaction is equals and opposite to the anodic reaction. The rate of corrosion is calculated by the corrosion current by number of electrons with kindness constant in terms of grams per second. So this is called as the electrochemical theory of corrosion. So which explains that the completely how the corrosion absorbed on the surface of metal. Now you can see in this picture it explains that this is the entire surface of the metal. The part of the metal which is undergo corrosion, iron into iron 2 place with electron. This blue color represents the water droplet. So due to that the reaction happens. Then afterwards the cathodic reactions are takes place and finally the rust deposition is observed on the surface of the metal. This is the pictorial representation of electrochemical theory of corrosion. So one of the important question in the point of examination, follow this video and it is helpful for your exam. Thank you.